Good morning. Welcome to another session on environmental impact assessment.
So we shall continue with Unit 2, Methodologies, Course Outcome, elucidate the methods of EIA with case studies, learning outcome, discuss the methods used in EIA, specific outcomes, explanation of the matrix method of EIA. So we are going to see the next method. We already seen checklist, we have seen ad hoc method first, then we have seen the checklist method, then we have seen the networks, now it is the matrix method. Matrix methods are basically generalized checklists where one dimension of a matrix is a list of environmental, social, and economic factors likely to be affected by a project activity. So there are two dimensions, to the matrix X and Y, right? So one of the dimension leads to the different factors. The other dimension is a list of actions associated with the development. These relate to both construction and operational phases, right? So when we go to some examples, you will know. So one dimension is the factors, other dimension is the list of actions associated with that particular development of the project. Making cells representing a likely impact resulting from an interaction of a facet of the development with an environmental feature identifies the impacts. Matrices provide cause-effect relationships between the various project activities and their impacts on the numerous environmentally important sectors or components. So this is helpful in understanding the cause-effect relationship. Right, you have a cause, then you have an effect. Something happened due to which, for example, something went wrong in the process of a factory, due to which it explodes. So the cause is something going wrong in the process. Effect is explosion of the plant. So matrices help in finding out the cause-effect relationship. Okay, so matrices provide a graphic tool for display impacts to their audience in a manner that can be easily comprehended. So just like in the network diagram, here in the matrices method, you will have a matrix which will be graphically presenting the impacts. Simple matrices, though able to identify first order effects, cannot show higher order interactive effects between impacts. So simple matrix cannot help you or cannot show higher order effects. Okay, I am not explaining what higher order effects is. I have done that in so many sessions earlier. Simple interaction matrices largely overcome this limitation. But such matrices are generally useful for depicting ecological interactions only for the sake of documentation. Disadvantages of matrices. The most serious criticism of such weighing matrices, which can also be extended to scaling and weighing checklists, is that they require large amount of information about the environmental components and project activities. Second, through the inherent aggregation process, decision making is in fact removed from the hands of decision makers and the public concern. A great deal of information that is valuable to decision making is lost in the conversion to number. Right, so it makes decision making a little more difficult. Why? Because you are converting everything in terms of numerical values, so it makes decision making difficult. Weights are assigned to environmental components and consequently to impacts without any guarantee that such weights and rating will represent the actual impacts that will be apparent once the project is implemented and operational. So weights are assigned, okay, but there's no guarantee that that rating and weights that are provided will represent the actual impacts that will happen when the project is started. Aggregation of numerical impacts through suitable transformation functions results in the combination of inherently different items into a single index or number, and hence leads to loss of information about the various impacts from the numerous project actions, thereby precluding the possibility of trade-offs by decision makers. So just like what we said in the previous slide, so everything is converted into some single index or number, so that leads to loss of information about what the actual impact is, and hence it is very difficult for decision makers to make a decision. Advantages of matrices. Matrices are strong in identifying impacts and unlike checklists can also represent higher order effects in interactions. Some of the dynamic nature of impacts can also be identified. They can also provide the functions of impact measurements, interpretation and evaluation, and can communicate the results in an easy understandable format to their audiences. But they cannot compare alternatives in a single format, and different alternatives need to be assessed and presented separately, right? So you cannot show all the different alternatives in a single matrix. That is the drawback of matrix method. Why? Because when you are saying some alternative, you'll have to draw another matrix. You cannot use the same matrix and say what are the alternatives. For example, you have drawn matrix for a particular problem. Maybe let us say the same paper production plant. You have drawn some matrix. Now, for some of the components, we are coming up with some alternatives. I have alternative 1, I have alternative 2, I have alternative 3. I have 3 alternatives. But this in a particular matrix, I can only show one alternative. If I have to show the second alternative, then I have to draw a new matrix. Otherwise, matrix will become very complicated and we cannot understand what is being written on the matrix. Right? It will become very clumsy. So that is the problem with the matrix method. The purpose of matrix is to help project manager to identify specific sources of potential environmental impact, provide means of comparing the predicted environmental impacts of various project options available, communicate in a graphic form the potentially significant adverse impacts for which a design solution has to be identified, adverse environmental impact that is potentially significant but about which insufficient information has been obtained to make a reliable prediction, right? Meaning there is an adverse impact which is significant, but there is not much information has been obtained, but that has to be represented properly using this matrix method. Residual and significant adverse environmental impacts, right? So you'll have to form a matrix to show all these things. So this is an example of matrix method, right? This is a pulp mill. So similar to what I said, it is like a paper mill. So paper pulp mill. So a similar one. Pulp is you have to make paper from paper pulp. So it's a similar example which I told in the beginning of the session. So here what you can see is that what are the environmental components? Surface water quality, surface water hydrology, air quality, fisheries, wildlife habitat, terrestrial wildlife, land use pattern, highways, water supply, agriculture, housing, health, socio-economic. So these are the components that are going to get affected. What are your project activities? Plant construction, right? Farming of canaf. I think it is the same thing, canaf farming. So the same whatever we see in network method, we discussed about this. The same thing has been represented here in the form of matrix. So use of pesticides and fertilizers, transport of raw materials, water intake, solid waste, effluent discharge, emissions, employment. Right? See, so these are the project activities. So if you take surface water quality, it is mapped to pesticide application. It is mapped to solid waste. It is mapped to effluent discharge. It is mapped to employment, because you need people to take care of the farming. So it is also related to employment, right? Surface water hydrology, it is only related to water intake. It is not related to any of the other things. Let's take air quality. Air quality, transportation of materials will release dust, but other things is all related to mostly water. So emissions, some dust coming out, emissions. Fisheries related to fertilizer application and effluent discharge. It is not related to any other things. Terrestrial wildlife habitat related to plant construction. Next one also related only to plant construction. Land use pattern only related to farming. Highways and railways related to transportation materials. It will not be related to any other things. Water supply, use of pesticides, effluent discharge. Agriculture, farming. Housing, employment. Health, health related to emissions, effluent discharge, solid waste. Socioeconomic conditions lead to employment. You cannot relate the socioeconomic condition to any of the other things. So this is just a small example of how to draw a matrix diagram, right? You have environmental components on the column and the project activities on the x-axis, right? And you have to relate how the environmental components are getting affected by each project activity, right? So let's close the session here as I'm running out of time. We will see in the next session. Thank you.
Thus, we come to the end of this session. Thank you for your participation. Looking forward to meeting you in the next session.